All right, so we're going to do examples 6, 7, and 8 in this video. I know I said I had 9 examples, but I just miscounted. So let's look at this particular example. So this function is not horizontally stretched or compressed. It's not, the fundamental period stays the same, but it is shifted, right? It has a phase shift. And so how do we solve for the fundamental solutions and the general formula when we have a phase shift, right? So the first thing we're going to do is we're going to find all the fundamental solutions without kind of taking into account this phase shift. So number 1, find the fundamental solutions. And so this is all the solutions within one period. Okay, so notice that the period of this function, because it's a tangent, is pi over omega. And omega is in front of theta here, so the period is going to be just pi, because omega is 1 or 180 degrees. So that means we want to find all the solutions from 0 to 180. Okay, so what I'm going to do is I'm going to go ahead and solve for this theta, okay, by tan inversing both sides. Right. So if I tan a tan inverse, these are going to cancel, and I get theta minus pi over 2. Or if we wanted to do degrees, you could just change pi over 2 to degrees, which I think I will on the next step. All right. Now if I do tan inverse here of negative rad 3, tan inverse is negative only in quadrant 4, right? But the calculator is going to give me a negative angle. So we're going to have to translate that, right? So if I do tan inverse of negative square root of 3, oops, I'm going to get negative 60 degrees. Now this doesn't count, okay, as a fundamental solution, because my fundamental solutions have to be between 0 and 180. So I'm going to go on a unit circle here. Negative 60 degrees is here, which is exactly where tan inverse is negative, right? So this is going to give me a tangent of negative rad 3. So I don't have an x-coordinate and a y-coordinate. I just know that tan of this angle is negative rad 3, right? So where else is tangent negative? All students take calculus, right? Tangent is positive in 1 and 3. So I'm really looking for the angle in quadrant 2. So if I kind of draw a similar angle here with a similar reference angle, the tangent of this angle should also be negative rad 3. Tan of this angle is also negative rad 3. Okay. So what is this angle in quadrant 2? Well, when rotated from 0, it's equal to 120 degrees, right? So I'm going to write my fundamental solution, and in degrees, I'm going to get theta minus 90 degrees. Instead of doing negative 60, I'm going to write it as 120, right? And then my fundamental solution, I need to add 180k to that, right? Because the period of tangent is pi, all right? So now, if I wanted to solve for theta, I just need to add 90. Now before we were dividing both sides, right? But when we add 90, we're just going to add 90 once to both sides. And I'm going to add it to the 120 because that's what its like term is, right? I'm not going to add, this would need a 90k in order to add here. So we just need to add it once to both sides. I'm going to get theta equals 210 degrees plus 180k. Right? These are my fundamental solutions when there's a phase shift. I'm just going to take that fundamental solution and shift it. Okay? And so if I wanted to find all the solutions from 0 to 360, I'm just going to play with the values of k here, right? All right, so if I were to do 210 plus 0, I'd get 210, right? Now in this particular case, if I let k equal -1 and subtract 180, I'm going to get another fundamental solution between 0 and 360. Okay? And then if I do 210 plus 180, then it's bigger than 390. Or it's bigger than 360 because it's equal to 390. So my two fundamental solutions are 210 and 30. Okay. Now why is that? All right. The reason why is if I were to plug in 30 degrees in here, okay, then I get tan of 30 minus 90 is -60, and tan of -60 is indeed negative rad 3. That's what we found here, right? So this 30 degrees, when plugged in here, still satisfies the solution. Okay, 210, if I did 210 minus 90, I would get 120, which is this solution up here, all right? So they do kind of make sense, all right? I wish I could ask questions. Questions? Oh, there's nobody here. I'm teaching to myself. All right, let's do example number 7. Two sine squared theta minus 3 sine theta plus 1 equals 0. So we're going to solve this quadratic trigonometric equation. So what we need to do here is we need to factor this, okay? The quadratic formula works, but I think it's easier to factor. Most of these examples will factor. Now, if you don't like to factor with signs in them, you can change them to s's, all right? So we're looking at 2s squared minus 3s plus 1 equals 0, or you could change them to x's if you wanted to. But basically, we need to find two factors that multiply to get us this quadratic. So let me go ahead and factor it for you. All right, multiply to 2s, so I'm going to get s and 2s. Multiply to 2, add to -3, so I need a -2 and a -1. So I'm going to get -1 here. Okay, so just to check. Okay, FOIL this. S times 2s is 2s squared. Minus s minus 2s gives me the minus 3s. -1 times -1 is +1. Okay, so here it is factored. Now what I'm going to do is I'm going to change the s's back to signs. All right. So to solve this, once I have it factored, I'm going to set each factor equal to 0. Right. So instead of s, I'm going to do sine theta minus 1 equals 0. And 2 sine theta minus 1 equals 0. And I'm going to solve both of these, right? First for sine theta and then for theta. So if I add 1, I'm going to get sine theta equals 1, right? And so then I'm going to sine inverse both sides. Okay, so sine inverse of sine cancels and I get theta. What's sine inverse of 1? What angle has a sine of 1? You should know, right? But if I sine inverse 1 on the calculator, I'm going to get 90 degrees. Right? So on the unit circle, right, sine is 1 here. This is 0, 1, right? And between 0 and 360, how many times is sine equal to 1? Just once, right? This is the only solution, okay? The only solution from 0 to 360, right? Now going over here, I'm going to solve for sine theta. So I'm going to add 1 and divide by 2. So I'm going to get sine theta equals 1/2. Then I'm going to sine inverse both sides. Okay, we've done this several times, right? It must be the book's like favorite one, right? What's sine inverse of 1/2? We're going to get 30 degrees, right? So once more, here's 30 degrees. This is where sine is 1/2. So where else is sine equal to 1/2? On the other side, right? With a reference angle of 30, so that makes the other angle 150 degrees, right? So we have 3 fundamental solutions. So when I write the general formula, the period of this function, all these thetas don't have an omega, right? So the period of this function is 360. So I'm just going to get theta equals 30 plus 360k. Theta equals 90 plus 360k. And theta equals 150 plus 360k, right? All right, final example here. Example number 8. Let's do 3 cosine theta plus 3 equals 2 sine squared theta. This particular example mixes cosines and sines. If possible, when you can, you want your trig equation to have only one trig function. So because there's a sine squared there, I can use a trig identity because we have that really nice Pythagorean identity, right? Sine squared plus cosine squared equals 1. So if I wanted to solve for sine squared, I just need to subtract cosine squared from both sides. And I get sine squared theta equals 1 minus cosine squared theta. Right, I can do that for the sine squared. I can't do that for the cosine. So I'm going to replace sine squared with 1 minus cosine squared, just so I have the same trig function. So I'm going to get 3 cosine theta plus 3 equals 2 times 1 minus cosine squared. Right? So I've got some algebraic manipulation to do here. I'm going to go ahead and distribute the 2. Okay, so we get 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. And again, it looks like I have a quadratic equation. I have a squared term, a linear term, and some constants. So I want to set this equal to 0. And when I do that, I want the squared term to be positive. So I'm going to go ahead and move the negative 2 cosine squared to the left, which means I'm going to add 2 cosine squared to both sides. Right? I'm also going to move the 2 at the same time, so I'm going to subtract 2 from both sides. So I get 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Right? So the quadratic formula would work here. Okay. So would the quadratic program on your calculator if you have it, right? But do know that that's what cosine equals. But this does factor, okay? So I am going to go ahead and factor it. 2c squared plus 3c plus 1 multiply to 2, add to 3, can do. So I'm going to get 2c and c, plus 1 and plus 1, right? So I'm going to get 2c squared, 2c plus 1c is the 3c, plus 1 and plus 1 is 1, right? So now that I have it factored, when I set it equal to 0, I'm going to go ahead and change the c back to cosine. So I get 2 cosine theta plus 1 equals 0, and cosine theta plus 1 equals 0. Alright, so I need to solve both of these equations. So I'm going to solve for cosine first. I'm going to subtract 1, divide by 2. Cosine theta equals negative 1/2. Then I'm going to cosine inverse both sides. Right? Remember when you do the inverse trig function here, cosine is negative in quadrant 2, right? So the calculator is going to give me an angle in quadrant 2. All right, so these are going to cancel. Cosine inverse of negative 1/2 is 120 degrees. So going on the unit circle, 120 degrees, okay, is 60 degrees shy of the 180 degree mark. And this is where the cosine is negative 1/2. Okay, and it doesn't matter what the y is. I just want the x value to be negative 1/2. Right? So where else on the unit circle do I get an x value of negative 1/2? Well, since I want the x to be the same, I'm going to go on the other side of the x-axis here. And I'm going to get my angle here. Here's my point. Negative 1/2. This time it's at negative y, right? But the y value doesn't matter. So this is 60 degrees on the other side. So my other solution is going to be 180 plus 60, which is 240. Okay, those are my two fundamental solutions. Going over here, cosine theta equals negative 1. If I cosine inverse this, okay, cosine inverse of negative 1, excuse me, where is cosine equal to negative 1? Okay, you should know this, but the calculator knows it too. All right, we get 180. So if you think about where cosine is negative 1, it's here on this quadrantal angle. Okay, and this function is 2 pi periodic, right? So if I were to do the unit circle and go around one time, where is cosine equal to negative 1? How many times? Okay, it's only equal to negative 1 once, and that's here. So this only has one solution, right? So to get to our general formula, I'm just going to take all three of these and add 360k to them. So I'm going to get theta equals 120 plus 360k, 180 plus 360k, and then finally 240 plus 360k. All right, for our general formula. All right, I did kind of look at the Pearson site today, and it was down for maintenance, so hopefully tomorrow it'll be up. I'll look at the homework. If there's anything else that I need to go over, I will be contacting you or posting another video with those different examples on there. But if you need help before then, please do not hesitate to email me and ask for a one-on-one Zoom tutoring session, or if you want to get with a group of you together and do a group Zoom session, I am more than happy to do that. So just let me know, guys. All right, take care.